Hello and welcome to another exciting Blender tutorial. Today we're going to be doing an introduction to geometry nodes using Lego. Okay, cool. So Lego is a really cool thing to create in Blender using geometry nodes. And I thought it was a really good foundation to start with. If you're new to geometry nodes, you want to wrap your head around it, you want to start exploring it more. It's a couple of key concepts that we can introduce really easily using Lego as like a building block. Oh, so here we are in the default scene. And the first thing I'm going to do is bring up my timeline. So I've got a lot of space here, and I'm going to click this little drop down and I'm going to switch over to geometry nodes. Now we're in the geometry nodes editor, but we don't have any geometry nodes in our scene. So I'm going to take my default cube and I'm going to click new. What this does basically is if you go over to the modifiers tab right over here, it's added a geometry nodes modifier and it's given it the default name, geometry nodes. Watch this. If I get rid of this modifier, you'll see that it disappears here in this bottom window. And if I click Add Modifier Geometry Nodes, and I click New here to create a new system, you can see I get a brand new geometry node system. Let's call this Lego Generator. You can see here, whatever I name it right here, it'll also name it here. And this will be a drop-down list of all the geometry nodes in my scene. All right, so first thing we want to do is let's disconnect the group input and group output. You'll see the cube disappears, and that's the first big concept of geometry nodes. The green pipe is, whatever goes into the output at the end, that's what you're going to see at the end. So if you don't have anything going into the output, you're not going to see anything. Even if you have mesh already, that you have the geometry nodes modifier on. Now, first thing we're going to do is we're going to create the basic shape of a piece of Lego. And Lego is made up of a cube. So let's go Shift A and type in cube. And let's go ahead and plug the mesh output into the geometry nodes output. You can see we're back to the default cube pretty much. And the other thing is a cylinder. So let's grab a cylinder. I'm just going to type in cylinder. Now I'm using Shift A to create stuff, getting the create menu, the add node menu. But it also lives up here. You can just click on add and find all the different types of things. But I like to do this, click search and type whatever it is I want to find. But if you're learning, it might be good just to go through and look at all the different options. You can see under mesh primitives, you've got all the different mesh primitives that you can create in geometry nodes. Let's have a look at the cylinder. I'll plug this one in, and there it is. But we want to combine these two. So we're going to use a special node called the join geometry node. So let's type that in, and I'll drop the join geometry node here, and let's plug the cube into it and the cylinder as well. And then let's take the output and let's put it into the output. Now nothing happened. What's going on? Well, it's because the cylinder is so big, it's actually on top of our cube. So let's define what this should look like. So I'm just going to kind of play around with this until I get something that I feel like looks like a Lego. And this cylinder is really tall, so I'm probably not going to want it to be this tall. So I'm going to drop its depth down to something like this, let's say, and maybe this cube's a bit too tall as well. So I'll drop the Z down to something, maybe to 0.5 on the Z. And the depth here, I'll take this down to maybe a little bit above 0.5, we'll say 0.5, and then we'll go up 1, 2, 3, something like that. Kind of looks like a Lego. But I've got this problem where it's poking out through the side. So how do you deal with this? Well, in geometry nodes, when you create primitives, you create objects within geometry nodes, each one of them starts off at the origin of your object, right? So if you want to move them around, you're going to have to change their position. And normally, if you're in Blender, you would hit G to grab and move them, but we can't do that here. We have to use a node to do it. And that's kind of the methodology, using a new node to do all the normal operations you would normally do. So let's grab the transform geometry node. If I drop this here, I've got transform properties, and now I can move this guy around. So you can see I can move him up a little bit. Let's move him up high like that, and then drop the depth down again. And you can see the depth is working off of the origin of this object, but the origin is down here. And this is a really important concept to recognize as well. So if this is set to 0, okay, let's just look at the cylinder for a second by itself, okay? If this is set to 0, I'm doing my depth. You can see it's going out from the origin, right? But let's say instead of using this for the depth, let's put this back to 0.5. Let's plug this into the transform again and plug the transform geometry into the output. So we're just looking at this. I'll just get rid of our join for now so it doesn't confuse us. And let's say we move it up first. Let's move it up 0.5, 0.25. There you go. So now it's sitting on the ground, right? Now let's do another transform geometry. Drop it here. I'll get rid of the Z there. And now instead of doing depth, let's do the scale. And you can see now it's scaling differently. It's no longer scaling from that origin point that we had back here. If we do the depth, it's now scaling from a new origin. And that new origin is defined by the position of this transform where we've placed it. So you can see if we put it way up here, right, and we scale, it's going to be scaling from down here. So wherever you move things with a transform geometry node, the origin stays static. It stays at that same origin point. So if you want something to kind of get taller or shorter from its base, what you need first is to use a transform geometry to get it to sit wherever its base is located. Then any transforms you do after that are going to affect it in that way you're expecting. So let's just go back to putting our Lego together. So I'm gonna put this back to 0.25, and I might bring my scale down a little bit. And let's grab that join geometry again. This kind of looks like a Lego. This is kind of cool. We've got some faces here, so we need to smooth those out. And let's go ahead and switch to rendered view as well, so we can kind of see what this is looking like in a rendered environment. So I'm just going to add a little floor, and I'll keep the floor at 0, 0, and you can see our cube is going below the floor, our Lego is going below the floor. We're going to correct for that so it sits on the ground. That'll make it a little bit easier, but we'll do that in a minute. All right, so let's go ahead and switch to render view. I'll turn off scene worlds, and I'm going to come over to my renders tab, and I'm going to turn on ray tracing. And then I'm going to take my floor, and I am going to give it a material. This is a little bit dark. How would we smooth this out? Well, normally what you would do is you would right click and shade smooth. You can see it's not doing anything on this object. Well, again, we're going to think, all right, maybe there's a node for it. So let's have a look. So I'll go Shift A, and let's go shade. There we go. Set shade smooth. We have quite a few options, but you see if we just drop this on, it's going to set it smooth, but it's going to do it for all of it, right? And I don't want all these edges to be smooth. So this is where we're going to talk about the next important idea about geometry nodes, and that's working with selections. Selection is something you're going to do all the time, but they can be a little confusing to get a hold of. Now, there's advanced levels of working with selections where you can create math operations to give you certain parts of an object and use that as a selection, but there's a lot of easy to access versions as well. Like, for example, on this primitive cylinder, you've got top, side, bottom as 3 different selection sets that are generated automatically when it's created. So let me move this here, and let's look at where we would use let's look at where we're going to use set shade smooth. I just want it to smooth along the outer, like the outer bit of the cylinder. So let's go all the way back to the cylinder, and you can see we've got this side output, and that's what I actually want to do. So I'm going to set this over here, way back at the beginning, and I'm going to use the side as the selection. And now you can see it set that to smooth, but everything else is sharp, and it just operates like a tick box. So now we've got the smooth sides we want. All right, so the next thing you might want to go is, all right, to make this look a little more realistic, it'd be nice if we had some bevel on these edges. So let's see, I'm going to try and add a bevel. So search for bevel, and no results found. So not every operation is going to have a node. Okay, so sometimes you have to find other ways of doing things. But thankfully, geometry nodes is a modifier that you can stack with other modifiers. So let's try adding another modifier on top. Let's add a bevel modifier. So I'm going to search for bevel, and we'll pop that in, and there we go. We've got a nice little bevel, and I could just set this to something really small and turn it up maybe to 3, maybe to 4. I want a really tiny bevel to make this look good. My geometry piece is selected here, but there's no geometry nodes showing up in my window. So what's going on? Well, one little trick that can be a little hard to remember or wrap your head around of geometry nodes is that it actually has to be selected for it to appear in the geometry nodes editor. So I've got my bevel selected. So this can really hang you up if you've got multiple modifiers on an object. So instead I have to click on the geometry nodes modifier for it to appear. Now you can get around that by clicking on this little thumbtack button. And what that does is it pins this geometry node system on the window, but you have to remember that it's pinned. So if you have another geometry object, and you're seeing, you're clicking it and you're like, why is it not changing? It's because you have it pinned. So don't forget that you have a pin, but this can help you not get tripped up. So let's think about how we might make more of these. So what you could do is you grab this all, Shift D, duplicate it, right? Bring it down here and have another join geometry, right? And plug this in. And then before you join them, just grab a transform geometry node, grab this first one, let's say, and move it on the X. And now you can see that it's duplicated, which is cool, right? But this is a bit cumbersome and it's not procedural. Now that might be okay, but you probably want to know how to procedurally do this. How could you take this base piece of Lego and let's put as many as we want all over the place. When you want to create a lot of different things, like a repeating thing or an object like this that's repeated over a lot of different places around your scene, what you want to do is instance that object in certain locations, wherever you're, in your scene file. And the idea of instancing is basically you take an object and Blender makes copies of it, more or less. They're all linked, so it's sourcing just from the original one. So if anything changes that original, they all update. That's the difference between a copy and an instance, right? An instance is always looking at the original thing, and whatever happens over there, it allows that to happen here. It's like the same thing. It's like a reflection or a photograph or a video conference call with the original object, right? So we got a bunch of Zoom sessions open, and they're all looking at the one object, right? And we see it all over the place, but it's still just the one object. Hope that makes sense. So in order to do that, first thing we want to do is generate some locations around our scene. So we can do that in a lot of different ways, but Blender in geometry nodes thinks of those little locations as something called points. And a point is kind of like a particle. It's not renderable. It doesn't show up anywhere. It's just a position in 3D space. So we can do this by creating some points. Let's just go with points. Points node. And the points node just generates some points. If I plug this in here, you can see there is a point. If I turn the count up, I'm getting lots of points, but they're all right on top of each other at the exact same place. And, you can't really see anything. They're kind of this diamond shape is what they appear. It's like a smooth shade diamond, but if you render this, you're not going to see it. It's not there. There's no renderable anything there. It's just showing it to us as a reference. It's got some, values like a position, but again, this is changing the position for all 11, all 10, all 15, however many you put in that count. They're all in the same spot. So how would you spread these out? Well, there's a lot of ways. You can instance them on something. So a common node that we use a lot is distribute points on faces. This node will basically take a mesh. So let's say we take this plane. I can drag this directly into my geometry node system, and I can plug this geometry output into the mesh. And now wherever this plane is, it's going to be generating points based on a density. Now it's smaller because if you look at our plane, you can see that we've scaled it up by 4.4, and the scaling on this object isn't taken into account in this geometry nodes because we're set to original. If you go relative, then it will take into account that scale. But anyways, you can see this crazy density. So we've got all these points, but the only thing that's determining where they go is where the mesh is, so where the faces of this mesh are. Now we could create a grid as well. Let's show you this. Mesh grid. All right, so what's a grid? Let's have a look. A grid is basically just a plane. If I hide the original plane here, so you can see with wireframe mode, it's basically just got 4 faces. Really simple. We could, turn up the size of these and increase the number of vertices, 5 and 5, right? And now these vertices on this object, each of these guys can be, Blender can think of them as a point. So that's another way to think about points, is basically the vertexes or the vertices on an object, a mesh object, can all be considered points, okay? But what do you do with a point? Well, you're always going to end up using the instance on points node. This node is very useful. You're going to use this all the time. And this is what we use to turn a point into an instance. Remember the Zoom call reference thing. So let's try that. I'm going to take my point here. I'll just set this to 1. So I just have 1 point. And I'll plug this into points here. I'll take instances and I'll plug this into the output. And then we need to say, okay, what is it we want to instance? And let's just say this guy over here. So let's go back to our shaded mode. So we've got the same result, right? But now we're kind of procedural. If I set this to 2, I've actually got 2 Lego pieces in the exact same place. Isn't that convenient? Naturally, you're going to want to have a bit more flexibility. Another way you can do this is, again, go back to the idea of vertexes being considered points by Blender. I could take this mesh and plug it into points. And now it's going to look at the position of each one of these guys, every single vertex here, and we'll instance one of these Lego pieces wherever these are. So this is kind of cool. You can see this is really useful. We can, use these maybe as like a procedural system for turning on or off multiple Lego. So very cool. Now, what we're going to do in this particular case is work with the points node. And I'm going to show you one other cool concept that makes geometry nodes very flexible, okay? Because my cube is 1 by 1 in its size, I basically want to move each one of these instances one, unit over, right? Each time I create a new instance, I'm going to move it 1 unit over in order for them to be perfectly lined up. How could I do that? How can I access multiple points when they're all stacked on top of each other and this position value is global? This is the hard part of geometry nodes, but if you can understand this, you can really start to fly. This is a diamond-shaped input, okay? Everything in geometry nodes that has a diamond-shaped input is an object that can receive some information that will loop through every ID in an object. So what's an ID? Let's open up the spreadsheet. Stay with me. I know you can do this. I know you can do this. Let's go to the spreadsheet. Where are you? There you are. And instances. Okay. So every time I create a new point, I'm getting a new entry in this. This is the spreadsheet viewer, by the way. It will give you data and information about the object you have selected, and it will show us all the stuff that Geometry Nodes is doing, basically. So every point is creating an instance, right, over here, and it's outputting an instance. That's why under the Instance tab, we see we're getting 8 different instances. And they have this thing here in the first row called an ID. And the first one, the ID is 0, then 1, 2, 3, 4, 5, and it just goes up, right? So each one has an ID. Each one has a unique position. Each one has a unique rotation and a unique scale. So when you see a diamond input, basically what that means is whatever you put in here, it's going to do it once for every single ID. So you can actually get different results based on what entry it is in the spreadsheet. What I want to do is I want basically each one of these to move on the X, let's say 1. So I'm adding up 1, 2, 3. But the first one, I want the first one to stay at the origin. So I want the first one to have a position of 0. Now what I'm going to do is I'm going to use what we just talked about as a clever trick for changing the position. Okay, now I'm going to use the ID itself as its position, because the first one I want it to be at position 0. So 0, there we go. The next one I want it to be at position 1, and the next one 2, the next one 3. So I'm just going to use the ID to position it, right? So as the ID, as we get more and more, as it goes through this ID, it's going to put it at a different place. So how would we do that? First we need to create a vector out of this, because the ID is just a single number, and we need this 3-number thing, which is called a vector, right, in Blender. And there's a node for this. If I just drag, it's a quick way to do it. Just click and drag and then let go. You get the little search. We're going to combine X, Y, Z vector. I'm going to grab this node here. This just allows us to input. It's the same as, to be inputting numbers here, but what I can do now is I can have a different sort of node system importing each one of these, right? Because I just want to change the X value. And I'm going to bring this out and I'm going to type ID. And this is going to grab the ID node. So when I drop that there, suddenly you can see we're getting the result we want. You'll also notice this dotted line, and that's a visual indicator that it's looping through each ID or each entry in the spreadsheet, right? For whatever the operation is. It doesn't have to be the ID node that's being used, but whatever it is, it's going through it for each one. And you can see it's taking the ID 0, puts it here, combines it into a vector. So this one is 0, 0, 0, and it puts it at position. And it goes to the next one in the count, 1. 1 comes into here. We have 1 for X, 0, 0. Makes it into a vector, puts it into here, and now it's at 1, 0, 0. And you can see these updated here in the positions for each of these. So each one of these guys has a new unique position, and that's how we can see it. What's cool about this is if I just keep ticking this up, they're going to be perfectly placed and line up just the way we want. So let's use this to do some other stuff. But first, actually, let me just expand on this concept just a little bit more so you understand it even more. So you can use the ID for all kinds of stuff. We can come over here and add a math node. I can come here. Now I can add a value to it. So it's going to add 2 to each of these as we go. I could multiply something. So now I'm multiplying 3. And you can see the 0, 1 stays still because multiplying my 0 stays 0, right? But the others are going to move further and further away. So you can get some really cool results. So that's how you can use an ID to kind of drive something on a case-by-case basis through each different point. So I'm going to plug this in here, go back here. So let's go out. How would you go the other way with this? Well, what we could do is let's create another instance on point node. And this time we're going to have this be the instance. So I'll plug this into the instance input. And then let's have another system like this. Bring this over here, and I'll set this to 2. And instead of going on the X, let's go on the Y this time. So I'll plug our ID into the Y, and then I'll plug this points into the points. And then let's come up here, and we'll replace the output with the other one. So now I've got one. It's basically doing the same thing, but it's going the other way, right? So now I've got this really cool grid system where I can just generate whatever size Lego I want. So how would you have this is something you could control? Well, if you go over here to the wrench, we go to our geometry nodes, we can come back to the node that we started with, the group input. One of the coolest things about the group input node is that it doesn't have to just output geometry. It can output anything. So we can grab this empty circle at the bottom of the group input, and I can drag it here into count. And then I can grab the next one, and I can drag it over here to this count. Now, if we come over to geometry nodes and open it up, you'll see I've got two values, and I can set these now to whatever I want and interactively generate Lego pieces. But what's cool is if I shift and duplicate this geometry nodes object, these numbers don't duplicate across all the different things that are using the same geometry nodes. This is the same geometry nodes. See, if I change the Z, let's say on this, you can see they're both changing, right? But because we've set it up with group input for the count, that stays unique to each object that has this geometry node system on it. So this way you can use one geometry node system to generate all different types of Lego. So I hope you really learned a lot about how it all fits together. Now let's take this a little bit further and do some polish to set this system up so we can do a few other things like height and stuff. So we're going to go back here to the cylinder and back over here to the transform geometry node, and let's figure out the basic height element that we want. So let's say our cube has a height of 0. What does that do for everything? Okay, let's get it to work with 0 first. So I'm going to take the size here, and I'm going to come out with a combine XYZ, and I'll set the X and Y to 1 because it's important. You may have seen that they're already 1 by default, so I'm going to make sure I keep that. And now the Z, I can just come out here and send this to a value node. Or even better, let's send it to the group output. So I'll just come over here and let's grab this. Okay, so now we've got this Z value, which changes the height. But let's set the base to be at the floor. So how do we do that? Basically, if we move up, if we set this to 0.5, where do we need this to be so that it's sitting on the floor? I think we should be able to move it up, I think half, whatever this value is, because it's half of it's going below the floor and half's going above the floor, right? So let's transform this geometry. Let's go for a transform geometry, drop this here. We're going to come here and grab another combine XYZ. This time we'll keep X and Y 0. And I want to take this value and do a math divide, and we're going to divide by 2. And I will drop this into the Z. So now we'll move up half whatever this height is. So now it's going to be doing what we want it to. So now we have a problem with the cylinder. The cylinder needs to move up as well, but how much? It needs to move up basically by this amount. So let's come over to our cylinder, and we've got all of this going on. So let's set this to 0. And let's figure the same kind of thing out for the cylinder. In fact, let's set this to 1. And let's get the depth to work for the cylinder as well. So I'll take this guy and I'm going to give it a depth of maybe 1, so 0.25 maybe. No, let's go smaller than that. 0.15 sounds good. And now I'm going to move it up. So same kind of thing, move it up on the Z, half of 0.15. So you can just go 0.15 divided by 2. You can just do math directly in the entries. So now it's sitting right where we want it to. And now I need to move this one up based on this value here. So I can grab a combine, and this time I don't want to do the math on it. So I'm not going to divide it. I'm going to take the height, plug it into the Z, and I'll plug this directly into here. So now wherever this Z value goes, that cylinder is going to sit on top and stay the correct height, which is awesome. So now we can do like really, low down thin pieces, like the big, bases that you can create in Lego like that. And that'll work out really nicely. All right, cool. Now, I don't know if you've noticed, but our bevel has stopped working. So what's going on with that? Well, now that we're working with an instance, bevel no longer works. Bevel doesn't actually properly handle instances. So we need to change these instances into something. And this is something you're going to run up to often, especially if you're applying a geometry node system to end up with a solid piece of geometry and getting rid of the modifier. We need to use something called realize instances. If I drop this here, realizing the instances will basically take each instance and it transforms it from a Zoom call looking at the original to just being its own unique piece. So if I make my bevel a bit bigger, you'll see what that looks like. Now we have a problem. It's beveling in between each one of these. We want it to look at this as one big piece. So let's grab this final bit here and let's set one more thing. Let's do the combine. No, let's, yeah, is it combine? No, merge. That's it. Merge by distance. And we'll just drop this here. The merge by distance node will merge anything that's has a bit of a distance to it. So I'll just turn this up. It's cool. Now you can see our cylinders are beveling at the bottom. So we need to drop them a little bit to get this to work. And we can just come back over here for that and just manually bring them down a little bit there and maybe bring the depth up a touch. Now, the last thing is, how would we put a material on this? Because if you notice, I've come over here to the material tab. If I have a material, it's not changing at all, even though we're in rendered view. Well, you actually have to set materials within Geometry Nodes itself. So let's go for a set material node. We'll drop this here and let's grab that red material. Bam, now we've got this nice red material on our objects. And what's cool is that we can even make that its own driver for this guy. So let's grab the empty, let's connect it to the material. So I come up, plug that in, and now you can see on the Geometry Nodes object, we have a tab for the material. And you can rename these and stuff. If you just open up the side panel, you can grab these and call them whatever you want, which is really, really cool. So I can switch this material now. And again, it's on a per object basis. So you can have different materials for each one. So that's a basic intro to the fundamentals of Geometry Nodes. How do you use it to create stuff? And I really think that Lego is a great way to explore that. I hope you have fun unpacking this tutorial and playing around with it. And I hope these concepts begin to make sense to you as you dive into this complex and really open-ended system. Now, again, we've just touched like the tip of the iceberg, but it's enough of a tip, at least, that you can begin to understand and find your way through the other parts. And it doesn't feel too daunting, hopefully, at this point. So thanks so much for watching. If you enjoyed this tutorial, hit that like button and don't forget to subscribe to the channel. Check out the Patreon, where you can get the full uncut version of this tutorial along with the project file. If you join this month, each month new project files come through, so check that out. You can also join on YouTube and support the channel there if you hit that join button. Thanks so much to everyone who already supports this channel. I really appreciate all of you. And thank you to you for watching all the way to the end. You're amazing. I'll catch you in the next one. Until then, have a fantastic week. See ya.